Hello and welcome back to AP Pre-Calculus. This is lesson 2.8, Inverse Functions. Alright, an inverse relation will undo a given relation, which means every inverse relation can be found by switching each x and y value. In some situations, this process is intuitive, meaning it's pretty basic. You kind of know what to do right off the bat. But other times it may not be so obvious. In these cases, it's important that we understand the concept of inverse relations, as they will help us tackle a variety of problems. We're going to be looking at this numerically, giving tables, graphically, pictures, and analytically, equations. Okay, so starting here with example 1, we have a table. We have x's and we have y's. Pretty straightforward. We switch them. All my y's moved up and became x's, and then all my x's became y's. We found the inverse. All right, the original table is a function because each x value has exactly one y value. However, the inverse is not a function because the input of 2 has two different outputs. Okay, for every one x there can only be one y, and the x of 2 gave me a 3 one time. Well, later on it gave me a 6, so that one is not a function. Let's look at a graphical problem. We have to find the inverse of this graph. We have to sketch it afterwards, and there are ways that you could do this with ideas, but I think the easiest way is with our ordered pairs, kind of like we did earlier in one of the earlier lessons with transformations. Let's pick some points. We have a point right here that is -2 comma -1, so my inverse would be -1 comma -2. So let's plot that. There we are. Let's go to the next point. Well, that's -1 comma 2, so my inverse is 2 comma -1. Let's plot it. Go over 2, down 1, there it is. Keep moving on. Let's go to this point right here. 2, 1. What's my inverse? 1, 2. Let's plot it. 1, 2. There it is up there. And our last one is 4 comma 3, which means my inverse is 3 comma 4. So where's that? 3 comma 4, way up there. And then if we just connect these dots with nice little straight lines, we have our inverse function. Wait a minute. Is it a function? It is not. It does not pass the vertical line test. So we have an inverse, but it's not a function. So if we look at example 2b down here, it says, is the original relation a function? And it'd be yes. It passed the vertical line test. Is the inverse relation a function? No, it did not pass the vertical line test. So listen, all functions have inverses. That doesn't mean that their inverse will be a function. It can be, but it will not always be. So we got to make sure that we can make that distinction. It will have an inverse, but it might not be a function. All right, let's look at this last thing down. Graphical property of inverses. The graph of inverses are reflections over the line y equals x. I'll show you that in just a second. So if you look at that green line there, that is the line y equals x, and I can fold that. If I fold that graph over that green line, both of those would end up being on top of each other. So it's a reflection over the line y equals x. Now let's look at it analytically, meaning we have an equation. Remember, we're switching x's and y's. That's all we're doing. But in this case, I don't really have a y. Well, I do, but I don't see it. So the first thing we might want to do is rewrite this. Instead of f of x, let's write it y equals 3x minus 7. Okay? Now I can switch my x and my y. And it's just the x and the y, not coefficient. No numbers move. Just the x and the y. And my last step is to solve for y. So I can add the 7 and then divide by 3. And I like to divide every term by 3. And I'm going to flip the order here if you don't mind. So I'm going to put it as 1/3 x plus 7/3, like that. And that's a line, okay? And that is a function. So we could rewrite this as f negative, that's how we show inverse, that little -1 up there, of x equals 1/3 x plus 7/3. Okay? If our inverse is a function, then we're going to rewrite it like this. Okay? And just as a side note, we could have made this a lot easier and done it like this. That's okay. But remember, we got to be able to recognize different ways to write our functions. So either one of those would get you full credit. Just know that they're the exact same thing. All right, so unfortunately here in AP Pre-Calculus, we have to find inverses of functions that might be a little bit harder than the ones that we've dealt with in Algebra 2. Finding the inverse of a rational function, meaning that we have x's in the denominator, make things a little bit more difficult. So I want you to read through those steps. We want to switch the x and y value, obviously. When I switch that x and the y, I'm going to end up having a y in the denominator, and I need to solve for y. And remember, that's one of the places that y cannot be if I'm solving for it. So we need to get off the denominator, and we do that by multiplying both sides by the denominator, right? And then we want to get all of our y terms on one side and all of the terms that don't have a y on the other side. Then we're going to factor out the y, divide, and then rewrite as a function, okay? So we have a couple of examples here. Let's get some room. Hopefully you have those steps written down. All right, so remember, this is a y. So I'm going to switch it. I'm going to make it the x, and then I got a y minus 2 on the top and a y plus 3 in the bottom. And if you remember, or if you haven't had me, you need to learn this, but if you remember having me last year, I said I don't like to see plus signs and minus signs in fractions. So let's go ahead and put parentheses around those, because parentheses are like curtains. They hide them from us. And now I have just a single term in the denominator, so I can multiply both sides by y plus 3. Well, I don't put it on the other side because I know that it's going to go away. And then we're going to distribute xy plus 3x equals y minus 2. And then I'm going to get all of my y's on one side and all of my terms that don't have a y. So let's go up here, all right? So I'm going to subtract the y. And I'm going to move the 3x to the other side by subtracting that. So it's negative 3x minus 2. Now I can factor. GCF, that's all this is. And remember, there's a 1 in front of that y, so it becomes x minus 1. And the last step is to divide. And if you wanted to put this in parentheses, I would love it. One more step, we should rewrite this as a inverse function. Just don't be crossing out those x's, okay? So there's your final answer right there. Go ahead and pause the video and give B a shot. All right, follow through those steps in blue and see if you got the right answer. All right, a little bit more on graphing inverses. So we know that to find an inverse, we just change the x's and the y's, right? We also know that graphically that we just flip it over the line of y equals x. It's the reflection over that. But sometimes it's not made up of simple line segments. We have some curves and stuff. So the first thing you want to do is sketch the line y equals x on your graph. Mark any points that are already on the line because they stay the same. They won't move. And then we'll select a few additional points on the graph and find their inverse points, right? You can do this just by switching the x or y. Let's see if we can figure out what all that meant on the last page. So I'm going to draw the line y equals x first. All right, there's my line y equals x. I have 2 points that are on that graph, right there and right there. So I'm going to mark those, and then I'm going to pick a couple of other points. So like this point, I think the easiest way is just to do the ordered pairs. This is 2, 0. So where would the other one be? 0, 2. So right there. And that would be the vertex of that one, right? I see a point up here at 0, 4. So let's come down here to 4, 0. And so now I know it has to go like this. And there would be my inverse. All right, let's try it again. So there's my line y equals x. I know that this point here, and this point here are going to stay. So I'm going to work on, like, there's a point I would like. That is 1, 0. So 0, 1 has got to be on there, right? So I got that point. Oh, there's a point I like. That's negative 2, 0. So 0, negative 2 has got to be on there. So that's down here, right? And then I'm going to use my high point, like my maxes and mins. That looks like it might be, I don't know, negative 1.2 and a little more than 2. So 2 to negative. So like right there would be my high point. Well, it's not really a high point now, but you know what I'm saying. This looks like 0.5 and negative 0.5-ish. So I'd go to negative 0.5 and 0.5. So I don't know, like right here. And then now I'm just trying to create this S shape. This is going to be terrible, but I'm trying. All right, so I come in here, come in this way, and there's my graph. So what do inverse functions do? If you plug a number into a function, it generally will output a new different number. For example, if we plug in a 2 into the function 3x minus 1, we're going to get out 5, right? But if we were to put that answer into the inverse function, which is, I wrote the inverse function down there for you. If we put the 5 back into that, we get back to 2 because we undid it. We started with 2 and we undid what we got out. So that's what they do, okay? This is because the inverse function will undo the original function. So if we plug any number, we'll call it x, into a function, and then plug the output that we got into the inverse function, we should end up with whatever we started with, so whatever that x was at the beginning. So inverse functions. Two functions, f of x and g of x, are inverses if and only if f of g of x equals x and g of f of x equals x. To show that two functions are inverse, we must show that the compositions equal x. All right, so let's look at example 6. We want to find the composition of these two. So f, I already know what g of x is, so it's 1/2 x plus 3/2. It's going to be ugly, but we can do this. So I'm going to do the f function, and I'm going to put 1/2 x plus 3/2 minus 3. Then I'm going to distribute, right? So 2 times 1/2 is 1, 2 times 3/2 is 3, minus 3, and I get x. So that part checks out, but both of them have to work out. So now we'll do the g function, and we got 2x minus 3. So I got to put it into the g function, 2x minus 3 plus 3/2. Distribute, 1/2 times 2x is x, minus 3/2 x plus 3/2, and again, we get x. So these are definitely inverse functions of each other. I am going to tell you that I kind of cheat the system here. If I've ever asked if they're functions, if they're asking me and I have to show it the way they want me to show it, I'd have to do this. But if all I need to do is figure out if they're inverse functions, I would pick one of them and find the inverse of that function and see if it looks like the other function. That's just like the cheater way to do it. So here in example 7, you'll see the note up at the top. It says sometimes we have to use a restricted domain to ensure the two functions are inverses, because remember, everything has an inverse, but the inverse isn't always a function. So if we're talking about inverse functions, sometimes we have to restrict the domain. So look at this one. We have a square root, right? What can we not have under square roots? Well, we can't have negatives, right? So they're saying that the domain has got to be greater than or equal to 10, because if it was equal to 10, we have a 0. I can take the square root of 0, but I can't take the square root of -1. I get imaginary numbers. So I'm going to be honest. If this was a multiple choice question and they just said, are these inverses of each other? I'm going to take one of the easier one of the two, change the x and the y, solve for y, and see if it looks like the other guy, okay? that's the quick and easy way. But seeing how this is not multiple choice, they want us to actually do it. So they want me to do h of k of x, and they want me to do k of h of x. So we got to do it that way, all right? So I know that we've got the square root of x minus 10. So when I take that input and put it into the h function, well, square and square root cancel each other out. So that part looks good. I get x there. Let's come over to this one. I have x squared plus 10. When I go to the k function, I go x squared plus 10 minus 10, and that's going to give me the square root of x. And I do. I get x for both of them. So yes, this one is definitely they are inverse functions. All right? Let's try example 8. Notice they took out 0 and 4 because we have x's in the denominator. And if I put a 0 in, p of x won't be it will be undefined, so that can't be there. And n of x, when I put a 4 in there, it's no good. So let's write it out. N of p of x and p of n of x. All right. I know that p of x is 6 over x plus 4. And then I'm going to put, oh, this looks gross. 6 over x plus 4 minus 4. That leaves me 6 over... Now, here we could do the keep, change, flip idea. You could multiply I like the idea of multiplying top and bottom by the common denominator. These will cancel out, and I get 6x over 6, which leaves me with x. All right, let's do the other one. P of 6 over x minus 4. All right, so we're going to have 6 over 6 x minus 4 plus 4. Well, that's ugly. So we need to clean this up a little bit. So if I multiply top and bottom by x minus 4, I'm going to get 6 times x minus 4 over 6. And these guys cancel out. So I get x minus 4 plus 4, which goes to x. All right? So some ugly fraction there, but if you remember some of the stuff we learned last year in Algebra 2, not too bad. And that ends this lesson.